వెల్కమ్ టు త్రినాథ్ కెమిస్ట్రీ క్లాసెస్. ఈ వీడియోలో మనం ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ ఆర్గానిక్ కెమిస్ట్రీకి సంబంధించినటువంటి ఆరోమాటిసిటీ అన్నటువంటి కాన్సెప్ట్ పై ఎంసెట్, ఎఫ్సెట్, నీట్ అండ్ జేఈ మెయిన్స్ పాయింట్ ఆఫ్ వ్యూలో చూడబోతున్నాం. సో మనకి ఈ ఆరోమాటిసిటీ అంటే ఏంటి అండ్ ఈ ఆరోమాటిసిటీ అన్నటువంటి కాన్సెప్ట్ పై బిట్స్ ఎలా వస్తాయి అన్నది డిస్కస్ చేయబోతుంది. సో ప్లీజ్ లైక్ ద వీడియో, షేర్ అండ్ సబ్స్క్రైబ్ ది ఛానల్. సో we know that organic compounds are classified into two types. One is open chain compounds and closed chain compounds. One is open chain compounds and the second one is closed chain compounds. So this open chain compound also called as aliphatic compounds. Open chain compounds are also called as aliphatic compounds. Open chain compounds are also called as aliphatic compounds and or closed chain compounds are also called as cyclic. Closed chain compounds are also called as cyclic. So organic compounds are classified into basically two types. One is open chain compounds and second one is closed chain compounds. So these open chain compounds are also called as aliphatic compounds and closed chain compounds are also called as cyclic compounds. And these open chain compounds are further classified into two types. One is saturated and unsaturated. Saturated and unsaturated. So the saturated means in which all the carbon 4 valencies are filled only with carbon single bonds. Then those are called saturated open chain organic compounds. Unsaturated means if it contains carbon double bond or carbon triple bond. Carbon double bond or carbon triple bond containing open chain organic compounds are called unsaturated organic compounds. So these closed chain compounds further classified into two types. One is homocyclic or carbocyclic. Homocyclic or carbocyclic. Second one is heterocyclic. So homocyclic means in the ring, closed chain means this open chain means it consists of long chains only. But closed chain means it consists of rings. 3-membered ring, 4-membered ring, 5-membered ring, 6-membered ring, n-membered ring. So this closed chain compounds, homocyclic or carbocyclic means whatever the ring forming, all or if ring forming elements are only carbon means, then those are called carbocyclic. If it consists of some hetero elements such as oxygen or nitrogen, then those are called heterocyclic compounds. So carbocyclic means it has only the ring forming elements as a carbon. If it consists of along with carbon, if some other elements such as oxygen, nitrogen is present, it is called heterocyclic compound. So these homocyclic compounds are further classified into two types. Carbocyclic compounds. One is alicyclic compounds. Second one is aromatic. Alicyclic compounds and aromatic compounds. So in this video, we are going to discuss what is aromaticity, when we will say a compound is aromatic, when we will say a compound is aromatic, and ఈ aromaticity కాన్సెప్ట్ మీద బిట్లు ఎలా వస్తాయి అన్నటువంటిది మనం ఇప్పుడు చూడబోతున్నాం. సో ఇక్కడ ఈ కాంపౌండ్స్ aromaticity కాన్సెప్ట్ మీద aromaticity కాన్సెప్ట్ మీద మూడు రకాలుగా క్లాసిఫై చేశారని కాంపౌండ్స్. వన్ ఈజ్ aromatic, second one is anti-aromatic, and third one is non-aromatic. So organic compounds are classified into three types based on the aromaticity. One is aromatic, second one is anti-aromatic, and third one is non-aromatic. So these aromatic compounds are further classified into two types. One is homocyclic and second one is heterocyclic. Aromatic compounds are further classified into two types. One is homocyclic aromatic compounds and second one is heterocyclic aromatic compounds. And these homocyclic aromatic compounds are further classified into one is monocyclic, second one is bicyclic, third one is polycyclic, and next one is annulins, and next one is polygons. So these homocyclic aromatic compounds are further classified into monocyclic, bicyclic, polycyclic, annulin, and polygons. Now let me discuss when we will say compound is aromatic. So a compound is said to be aromatic. If it is cyclic. A compound is said to be aromatic only if it is cyclic, and it consists of conjugated and delocalized over entire ring. It should be. So a compound is said to be aromatic if it is cyclic and it should be conjugated and delocalized over entire ring. And third one is it should be planar. And it should obey Huckel's rule. That is 4n plus 2 pi electron rule. So a compound is said to be aromatic if it is cyclic and it should be a conjugated and delocalized over entire ring. And third one is planar. And fourth one is it should obey Huckel's rule. That is 4n plus 2 pi electrons. That is number of delocalizing electrons should be 4n plus 2. Then the compound is said to be aromatic. And anti-aromatic means. So this is regarding aromatic. So anti-aromatic means. One is it should be cyclic. Second one is it should also have conjugated and delocalized over entire ring. And third one is it should be planar. And the fourth one is it obeys 4n plus pi electrons. 4n plus, that is 4n number of delocalizing electrons. It should have 4n number of pi electrons. Pi electrons. Then it should be anti-aromatic. And the third one is non-aromatic. Non-aromatic means the compounds which are neither aromatic nor anti-aromatic. Anti-aromatic are called as non-aromatic. So a compound is said to be aromatic only if it is cyclic. Then it should have conjugated and delocalized electrons, delocalized electrons over entire ring. And third one is it should be planar. And the fourth one is it should obey Hubble's rule, that is 4n plus 2 pi electrons rule. That is, it should have 4n pi 2, or 4n plus 2 number of electrons. 4n plus 2 number of delocalizing electrons. Then anti-aromatic means it should be cyclic, it should be conjugated and delocalized, it should be planar, and it should have 4n pi electrons. 4n pi number of delocalizing electrons. Now, let me take some examples and explain. For example, if you take benzene. So if you take in benzene, so it is cyclic, and it is planar, because in benzene we know that carbon is in sp2 hybridization. Third one is it should obey 4n plus 2 electrons. That is 4 into 1 is equal to 6. So there are 6 delocalized pi electrons. That's why benzene is an aromatic compound. Let me take one more example. If you take naphthalene, so it is cyclic, because in this all the 10 carbons are in sp2 hybridization. And third one is it has 4n plus 2 pi electrons. That is, if n is equal to 2, that's why 10. That's why 1, 2, 3, 4, 5. So there are 5 pi bonds. That's why it has 10 pi electrons. That's why it is aromatic compound. So in this aromatic compounds, the delocalizing electrons may not be always pi electrons. So like in benzene, whatever the delocalizing electrons, if you take in benzene, all the electrons which are in delocalization are in pi electrons only. But the delocalizing electrons may not be always pi electrons. They can be lone pair of electrons also. For example, if you take, so this is ferrule. So how many pi electrons are there? Here there are only 4 pi electrons, 2 pi bonds. That's why it has only 4 pi electrons. But there is one lone pair on nitrogen. So it will be in delocalization with these pi electrons. That's why the total number of delocalizing electrons are 2 pi bonds, 2 into 2 plus 1 lone pair, 1 into 2. That's why it is obeying Hubble's rule. So here a compound is said to be aromatic only if it is cyclic, and it should be conjugated and delocalized over entire ring. And third one is planar, and fourth one is it should have 4n plus 2 number of delocalizing electrons. That delocalizing electrons may not be always pi electrons. So like in benzene, benzene has all delocalizing electrons are pi electrons. But if you take in this case, the delocalizing electrons are not all pi electrons, because there is one lone pair of electrons on nitrogen which is participating in delocalization. So similarly, one more point in this aromaticity concept is, suppose Second point is, if an atom contains, two or more lone pairs, lone pairs, we have to count only one lone pair. Count only one lone pair. One lone pair delocalizing electron. One lone pair delocalizing electron. If an atom contains two or more lone pairs, count only one delocalizing electrons. So, for example, if you take this compound, thiophene, you take this thiophene, so it has two lone pair of electrons on sulfur. Right here, the sulfur atom has two lone pairs. But we have to count only one lone pair. The one lone pair only participate in delocalization. That's why here we have to count only one. Then third case is, sometimes the lone pair may not be involved in delocalization. The lone pairs will be present, but lone pairs may not be involved in delocalization. So even though lone pairs are present, the lone pairs may not be involved in delocalization. If it is associated with whatever the lone pair, it is associated with pi bond. So in that case, the lone pair should not be counted. For example, if you take pyridine, so in pyridine, nitrogen has one lone pair of electrons. So here there are 3 pi bonds. That's why 3 into 2, how many electrons? 6 electrons. 3 into 2, 6 electrons. So the whatever lone pairs on nitrogen do not involve in delocalization. So this is the next one. So next point is, suppose if carbanion is present. So we know that carbanion means negatively charged carbon containing species is called carbanion. Negatively charged carbon containing species is called carbanion. So if carbanion is present in conjugation, if carbanion is present in conjugation, if carbanion is present in conjugation, it is considered as planar due to involvement of lone pair in conjugation. And it loses non-planar character. Let me take one more example for this. So here, so this is cyclopentadienyl anion. So in this compound, whatever the negatively charged carbon containing carbon is involved in delocalizing conjugation. So hence it should be considered as a planar. So total number of 2 pi electrons and one lone pair on this carbanium. The total 6 pi electrons. That's why it is an aromatic compound. It is an aromatic compound. So, in objective point of view, so questions how will be asked means, so maybe వాళ్ళు 4 కాంపౌండ్లు ఇచ్చి ఏది అరోమాటిక్ అని అడగచ్చండి ఒకటి. రెండు, ఏది యాంటీ అరోమాటిక్ అని అడగచ్చండి. సో ఫర్ ఎగ్జాంపుల్ ఈ 4 కాంపౌండ్స్ ఎలా ఇచ్చేటండి, ఇలా 4 కాంపౌండ్స్ ఇచ్చండి, ఏది అరోమాటిక్ ఏది యాంటీ అరోమాటిక్ అని అడిగారు. సో అడిగితే కనుక బెంజిన్ ఇస్ అన్ aromatic compound. So pyridine is also, it has 6 pi electrons and that's why it is aromatic. Here also there are 6 delocalized electrons, that's why it is aromatic. But it has only, option B has only 4 pi electrons. That's why it is anti-aromatic compound. It is anti-aromatic compound. So let me take one more example. Cyclopropanone is an aromatic, B non-aromatic, C anti-aromatic, D aniline. ఇలాగ ఆప్షన్ అడిగారు. సో ఫస్ట్ అసలు సైక్లోప్రోపినోన్ అంటే ఏంటో చూస్తే కనుక ప్రూప్ అంటే ఎన్ని కార్బన్ రావాలి, 3 కార్బన్స్. సో ఈ ఇన్ అన్నారు అంటే కార్బన్ కి డబుల్ బాండ్ అండ్ సో దిస్ ఇస్ కాల్డ్ సైక్లోప్రోపినోన్. దిస్ ఇస్ కాల్డ్ సైక్లోప్రోపినోన్. అంటే ఇలా రింగ్ కింద రాస్తే కనుక సైక్లోప్రోపినోన్ అని చెప్పి. సో ఇప్పుడు ఇది aromatic or non-aromatic, anti-aromatic అని అడిగేట అనుకోండి. సో దిస్ ఈజ్ అన్ aromatic compound. This is an aromatic compound. So how it is aromatic compound అంటే కనుక మనకి ఇందులో ఉన్నటువంటి బాండ్ ఎలా పోలరైజ్ అయితే కనుక దీని మీదకి పాజిటివ్, దీని మీదకి నెగిటివ్ వస్తుంది. Right? That's why it has only 2n pi delocalized electrons. That's why this positive charge is delocalized with this pi bond. That's why this is aromatic compound. This is aromatic compound. Let me take one more example. So which of the following is an aromatic compound? Which of the following is an aromatic compound? So which of the following is an aromatic compound? అంటే కనుక మనకి ఇదిగోండి ఇలా 4 కాంపౌండ్ ఇచ్చారు. సో ఆప్షన్ ఏ తీసుకుంటే కనుకండి it is not an aromatic, because even though it has only 2 pi electrons, but here there is an sp3 carbon. That's why it is a non-planar. If you take this one, it doesn't have 2n pi electron, 4n plus 2 pi electrons. That's why it is not aromatic. So this is an anti-aromatic compound. So the option C is an aromatic compound, because in this the pi bond is delocalized with this pi bond, and it is an aromatic compound. It is an aromatic compound. So some other examples for aromatic compounds are cyclopentadienyl anion. Cyclopentadienyl anion. This is an aromatic compound. This is an aromatic compound. This is an aromatic compound. Similarly, cycloheptadiene Trianyl cation. Trianyl cation is also aromatic. One, two, three, 4, 5, 6, 7. So in this case, this pi bond is in delocalization with this. The positive charge is in this delocalized with the pi bond. That's why this compound is aromatic as it is cyclic, planar, and delocalized. And this has 4n plus 2 pi electrons. 4n plus 2 delocalized electrons. 4n plus 2 delocalized electrons. That's why this is an aromatic compound. Similarly, if you take anthracene, anthracene is also an aromatic compound. Anthracene is also an aromatic compound. So, in this way, questions will be asked from this aromaticity concept. So, basic వాళ్ళు ఒక అసలు aromaticity అంటే కనుక it should be cyclic and it should be planar. It should be delocalized and conjugated and delocalized, and it should have 4n plus 2 pi electrons. So aromatic నాన్ aromatic అని అడిగితే కనుక అది సైక్లిక్ అవుతుందో అవ్వట్లేదో, 2 అది ప్లానారా కాదా, 3 ఇట్ హ్యాస్ ఎ కాంజుగేటెడ్ అండ్ delocalized సిస్టమ్ ఉందా లేదా, దానికి 4 4n plus 2 delocalized ఎలక్ట్రాన్స్ రూల్ ని ఒబే చేస్తుందా లేదా, అంటే దట్ ఈస్ హకుల్స్ రూల్ ని ఒబే చేస్తుందా లేదా. సో ఒబే చేస్తుంటే కనుకండి aromatic. అండ్ ఒకవేళ కనుక సైక్లిక్ అయి ప్లానార్ అయి మూడోది వచ్చేసరికి ఏంటంటే కాంజుగేటెడ్ అండ్ delocalized అయి 4n plus 4n నెంబర్ ఆఫ్ delocalized ఎలక్ట్రాన్స్ మాత్రమే ఉంటే కనుకండి అది యాంటీ అరోమాటిక్ అంటాం. అరోమాటిక్ కానీ యాంటీ అరోమాటిక్ కానీ కాంపౌండ్స్ ఏవైనా కూడా ఏమవుతాయి అంటున్నాం, నాన్ aromatic. ఏమని చెప్తున్నాం ఇక్కడ, నాన్ aromatic. సో this is regarding aromaticity. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.